Hello and welcome to Software Architecture course. Today in this lecture we are going to talk about agile methodology. So bit of an introduction of this lecture. Agile methodology is basically a topic by itself, and possibly it has been covered in other courses of software engineering. So I'm not going to repeat and not going to cover the entire agile methodology, but basically give a very brief overview just for the sake of completeness, and specifically focus on the software architecture part of it. So it's going to be a brief lecture on agile, but not agile methodology completely, but focusing primarily on the software architecture part. Just an introduction, what is agile methodology? Agile methodology is basically an approach where one can build software with a very tightly coupled team and basically build it really fast. By that what I mean is, it is not the case that by agile one can build an application faster than a traditional waterfall approach, but here the idea is to have a very short turnaround time and have a lot of incremental releases and so on. So one of the hallmark of agile methodology is basically collaboration, in which there are pair of people, they form a team, a very short team, they form the pair, and for any development task there are two people basically to avoid error. One person does the work, other person observes or reviews it, and they exchange their role. Another important thing is that they involve in this approach the stakeholders of the system, and they are involved from the beginning. If you recall, in our software architecture course, at the very beginning when we introduced software architecture, we had spent quite a bit of time in highlighting the importance of stakeholders. Without the stakeholder, this software architecture is meaningless, because one has to really understand who the stakeholders are and then create the architecture to satisfy those stakeholders' requirements or concerns. In agile methodology, it is done in the process itself, where they try to involve the stakeholders right from the beginning. So there is, in my opinion, there is not much of a clash in terms of philosophy of as agile method of development versus what we understand by software architecture today. It is interactive and feedback oriented. Teams interact with each other very frequently. In fact, they spend much less time in basically deciding a grand strategy, but basically work on some small things, small steps, really quick. Repeated integration of the product, constant feedback from the customer. These are extremely essential for agile. It is iterative, so though it follows the sequence that one has to do requirement followed by design, then coding, testing, but this sequence is repeated over many iterations, and each iteration is a very short duration. Refactoring is essentially a part of the development process, because agile philosophy is that one cannot really come up with the most perfect design and solution in the first place. In fact, in reality, most of the software projects suffers from this problem of constant change. So if this change is not a part of the process, then the whole process, whole software development process will fall flat. It will have a cost overrun. But if those change management is a part of the process, it is managed in a structured manner, then possibly a software can evolve in a much more structured way. It doesn't have any haphazard impact there. So in the case of agile methodology, as I said earlier, that they get the requirement, do the design, if not the full requirement of the entire system, but at least a part of it. But important part is that even for that part of the system, whatever requirement that they get, they design, code, and show the prototype and move on. And then if the next requirement requires a refactoring, then they go ahead and then change the product and then add the new feature. But important part is that it is a continuous integration. As and when new features come in, the continuous integration. Therefore, it is quite obvious that it needs to be test driven, because without testing you cannot just have this incremental approach. So test driven development is hallmark. It's a very essential important for agile development. In fact, before building a component, one needs to define the test cases, and they suggest that one needs to continuously test. So these four characteristics are actually defined by the father of agile methodology, Scott Ambler and Ken Beck. So brief overview. There are 7 disciplines which are performed in an iterative manner. At each iteration, as I said, a software or a part of it is built and tested. So software architecture, which is essential component in this entire development process, is much more agile. It is not a frozen kind of thing. It is not you design it once and then never change it. It is agile and it is never frozen. So therefore software architecture is much more close to the design and implementation. By that what I mean is, in a traditional software development scenario, because software architecture is, though it is not mentioned anywhere that one has to design architecture for once and never change it, it is nowhere mentioned. But in a traditional software development process, people design the software architecture once and then they go ahead and then do the design test and so on. But typically architecture is never revisited. As a result, there is a big gap between what was there in the architecture and what has been implemented, because requirements keep changing. New ad hoc requests come in for that. It is not reflected in the architecture, so things are modified in the system. Bug fixes, major changes happen. As a result, the code is quite different from what is the architecture. So it's called code drift or architecture drift. In agile, architecture drift is kind of controlled, and they try to make sure that the architecture is close to the implementation. UML based modeling is performed, but UML 2.0, as we have already discussed, UML 2.0 is quite complex, has too many models. In Agile, they suggest that UML should be used with its minimal set of components and modeling constructs. It shouldn't be overused. All the models that are proposed in UML 2.0 are not really necessary. Bare minimum UML models are good enough for Agile. In fact, whatever we have covered in our course, software architecture, that should be good enough for the agile model. So pictorially, this is what it looks like in agile development. So these brown rounds are essentially releases, and the diamond is version. So there are continuous releases. These are called development release or dev release. They keep on happening, and at times stakeholders are always involved even for the dev release. And after a sufficient number of dev release, they release a formal version. So in this case V1, and then again a series of releases happen. Then again next release, which is V2. Then again a series of releases happen, V3, and so on. So these blue diamonds are essentially more important release. Maybe it should be put in the production environment, but the dev releases need not be put in production. But it is highly encouraged that in each of these releases, stakeholders are involved. Let's look at the discipline overview. We said that there are 7 disciplines. I will highlight only important ones. First one is called model. In that, so model is kind of an activity. People do business model as well as analysis and design, which is architecture. In fact, a business model is also a view of architecture. Business analysis and design, they all form the architecture. Then it's implementation, test, then deployment, configuration management, project management, and managing the environment where it is running, of which model part is of our interest, where one creates architecture and recreates architecture as and when new features come in. These are always changed, and model and implementation are very tightly coupled. So it is basically feature driven. There are a bunch of features which are basically identified, then they are prioritized. The critical features, according to the priority, are elaborated more. So architecture for those critical features should be elaborated in much more detail than non-important features. Model the architecture typically using UML diagrams. Agile methodology suggested a few set of viewpoints like usage scenarios, user interface and system interface part of it, network deployment, hardware, data storage and data transmission, code distribution are essential viewpoints that Agile methodology suggests that one needs to have at least these viewpoints in the architecture. If you recall, when we discussed about views, architecture views, all these points like usage scenarios, user interfaces, network deployment, hardware, data storage, transmission, code distribution, they're all covered in different names. So I would suggest that you go back to the lectures related to architecture views and see how these agile viewpoints can be mapped. You will see that they can be mapped very easily. Suggested quality concerns, they suggest that one need to focus on reuse, reliability, availability, serviceability, performance, security, internationalization, regulation, maintenance, and so on. So many of these quality concerns we have already covered in great detail. So the techniques that we have discussed, those quality tactics that we have discussed in our earlier lecture, they would all be useful in agile model. Let's look at a specific technique during analysis and design of identifying the classes and their responsibilities once you have the requirement. This is called the CRC card. Earlier it was a physical card, now it is an electronic card. One card is basically for one class. It indicates the responsibilities of a class, and it has another part which basically describes the collaboration. Sometimes a class can fulfill its assigned responsibilities on its own, but sometimes it requires help from other classes. So it's a very good technique to identify a class and its responsibility during functional architecture design. It is highly collaborative. There are a bunch of architects or maybe designers who sit, they're very tightly coupled, and then they collaboratively create this CRC card or other card deck, and then from there they come up with a set of useful classes. The team can do it really fast. Let's look at a sample CRC card, how it looks like. It has got the class name, then it has got the responsibilities assigned to this particular class, and another part is called the collaborators, the class collaborators. So as I said earlier, if this class cannot fulfill any of its assigned task on its own, then it basically identifies what are the other classes that can help this particular class to fulfill its responsibilities. So the responsibilities are assigned to this particular class on the left hand side of this card. So one exercise could be that you could try create a CRC card for a box class where the responsibilities would be getting the length, getting the width, getting the height, and then compute the area and volume. You could write it like this, that this is the box having responsibilities length, width, height, and computing area and volume. In this case there are no collaborators. Well, you can now guess what are those responsibilities. They basically form methods of this particular class, and you can basically have a class like this. Very simple example, but in more complex cases a class will not be as simple as a box. It could be a more coarse-grained class, much more coarse-grained, which may need to be refined for more fine-grained classes. That's quite possible. In fact, using CRC approach, there is no way one can control this granularity. Some might be as low level as a box, something could be even pretty high level at a business process level. So one need to really cut it down, and once first version of CRC cards are there, one need to drill down and then create a few more classes for those very coarsely granular components. Another example, write CRC cards for two classes A and B. Here it looks like, let's say this class B has some method or some responsibility which is called do B, really a silly responsibility, but just to highlight the point. Class A, it has its own responsibility called do S, but it requires B to fulfill its own responsibility. Remember, on the left hand side I am showing those class examples, but in actual scenario you are not going to have these classes, because classes are nothing but implementation. What we are talking about architecture, it is much before implementation. So you got the requirement and then you need to basically create these classes. From these classes only you are going to have the implementation that I have shown on the left hand side. But I have shown this implementation just to highlight that how these methods, class names are related to the CRC card, so that you understand what you need to put in the CRC card when it's given to you. So essentially this is what it is. How do you create a CRC model? These are the steps. You basically find the main classes, the top 10 classes, actors, main modules, define their responsibilities. Once you define the responsibility, for each responsibility you think how it can be implemented, and then that will basically give you a clue that whether you need some collaborator. And then once you are done, then one iteration is over. Then you basically move the cards, again group those cards based on who collaborates with whom, and then iterate it again, because in the next iteration the cards that you have created, some of them may have to be discarded, some you may have to split into multiple classes, some may have to modify. So this is how it continues in a loop, and then after some time it becomes more or less stable. Then those are your set of high level classes or components. So that's all for the agile methodology. I basically focused on the architecture part of it. I deliberately did not touch upon the other part because those parts are really not in the scope of software architecture. Thank you.